Good day, learners. Welcome to Mathematics lesson. My name is Nonkululeko Mboyisa. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. In today's lesson, we'll be looking at the revision of functions and algebra. Last week, we have done the revision of functions. Remember, in your paper 1, which is out of 150, your functions, they weigh 45 plus or minus 3 marks, and your algebra, it weighs 45 plus or minus 3 marks. So if you know your functions and you know your algebra, it means already you have 90 out of 150 marks. Okay, at the end of this lesson, learners should be able to solve equations using laws of exponents for rational exponents. You should be able to solve simple equations involving sets. Number 3, you should be able to solve quadratic equations by factorizing and using the quadratic formula. Number 4, you should be able to solve inequalities in one unknown. Number 5, you should be able to solve problems with the nature of the roots. Also, you should be able to solve equations with two unknowns, or one of which is a linear equation and the other is a quadratic. You should be able to sketch an algebraic graph, and you should be able to interpret graphs by finding the x and the y-intercept. You should be able to find the turning points in a parabolic graph, and you should be able to find the asymptotes, the axis of symmetry, maximum and the minimum values. Okay, let's look at question 1, which was extracted in a previous question paper. 1.1.1, they say we must solve for x when you are given x into 2x plus 1, close the bracket, it is equals to 0, and it is 2 marks. So with this kind of a question, it is already factorized. So when they say solve for x, you don't have to factorize because already it is factorized since it is equals to 0. All right? So what you do is that you'll just say x into 2x plus 1, it is equals to 0. You'll say x, it is equals to 0. Or 2x plus 1, it is equals to 0. So 2x, it is equals to, if you take 1 to the other side, it becomes negative 1. You divide by 2, you divide by 2, then your x would be equals to negative 1 all over 2. So you'll get your 2 marks. You get a mark for x, it's equals to 0, and you get a mark for x, it is equals to negative 1 all over 2, and that's your full 2 marks. So sometimes other learners, they decide to say x times 2x and x times 1, then they use the quadratic formula. It's still okay. You're still gonna get full marks because you get a mark for saying x, it is equals to 0, and a mark for saying x, it is equals to negative 1 all over 2. Okay, let's move to 1.1.2. 1.1.2, you're given that 5x squared plus 2x minus 6, it is equals to 0. They say you must solve for x and correct your answer to 2 decimal places. So in a question like this, whereby they say you must correct your answer to 2 decimal places, sometimes they do penalize you a mark for not rounding off correctly. Okay, I'm gonna have to erase here. Okay, so you are given that 5x squared plus 2x minus 6, it is equals to 0, right? So you can see this is a trinomial, or it's a quadratic equation, because it is given in a form of ax squared plus bx plus c, it is equals to 0. So your a, it is given as the 5, then your b, it is given as your 2, then your c, it is given as negative 6. You just use your quadratic equation because you can't factorize it, since they're saying you must correct to 2 decimal places. So it means you need to use a quadratic formula. So you say x, it is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x, it is equals to negative, your b, it is given as 2 plus or minus the square root of 2u square minus 4. Then your a, it is given as 5, and then your c, it is given as negative 6, it is all over 2. Then your a, it is given as 5. So your x, it is equals to, just substitute everything in your calculator. So you'll get negative 2 plus the square root of 2 squared minus 4 into 5 into negative 6 all over 2a, which is 5. Ne? So you'll get that your x, it is 0, 9135. So they said round off to 2 decimal places. So since the third number after the comma, it is less than 5, you're just going to take the 0, 91. Then the other one, you say x, it is equals to, you go back, you check, you change, and you substitute with a negative sign. Then you will get a negative 1, 31. Since the third number after the comma, it is 3 and it's less than 5. So you just take just 31 as it is. Then you get your full 3 marks for doing all of that. So you'll get a mark for the correct substitution. You'll get a mark for x, it is equals to 0, 91, and you get a mark for negative 1, 31. So always when they say solve for x and it's a quadratic equation and they say correct to 2 decimal places, you just use a quadratic formula. Let's move to the next question. The next question, you have 2x squared minus 2, it is greater than or equals to 3x. And it's 4 marks. They say you must solve for x. So because the sign here, it is greater than or equals to instead of an equal sign, it means we are solving for an inequality. Ne? So you have 2x squared minus 3x. Okay, let me just minus 2, it is greater than or equals to 3x, right? So first things first, we must write it in a standard form. In a standard form, meaning that you'll write it in a form of ax squared plus bx plus c. Ne? So I'll take the 3x to this other side, and then it's going to change the sign to be negative. So I will have 2x squared minus 3x minus 2, it is greater than or equals to the 0. Ne? And then your a, it is given as the 2, this 2. Then your b, it is given as negative 3. Then your c, it is given as your negative 2. Ne? So you say critical values, then you can just factorize, or you can also use the quadratic formula. Ne? So x, and then I'll get, it is going to be 2x plus 1, and then it is going to be x minus 2. Let me just double check my answer. Okay, so if I say 1 times negative 2, I get negative 2. And if I say 2x times the x, I get 2x, and 1 times x and 2x times negative 2, I do get negative 3. Ne? Okay, so from here we find your critical values. So you'll say 2x plus 1, it is equals to 0, or x minus 2, it is equals to 0. Right? So you'll say 2x, it is equals to negative 1. You divide by 2, you divide by 2. Then you'll get that your x, it is equals to negative 1 all over 2. Or if you transpose the negative 2 to the other side, you'll get x, it is equals to positive 2. Name, you're not done. Here you'll only get 2 marks for the standard form, and you'll only get a mark for those critical values. Name. So you still need to continue to draw your number line. So if you check nicely, you can see that your value of a here, it is given as positive 2. So it means your a, it is greater than 0. Remember, this is a quadratic expression, so it means it's a parabola. Ne? So you've got a, it is greater than 0. So if your a in a parabola, it is greater than 0, then it means your graph, it is going to concave up, or it's going to smile. Ne? So let's say this are your x-axis, and then you just put your graph of a parabola. Then you start with the number that is the lowest, which is -1/2, and then you put your 2 on the other side. Okay, so your values of y from the x-axis going up, they are going to be positive, right? From your x-axis going up, you've got your values of y is positive. So it means all your values of y this side, they are positive. And then from the x-axis going up again, the values of y, they are going to be positive, ne? And then from the x-axis going down, your values of y, they are going to be negative, right? And then you go to your equation that you are given. They're saying you are looking for the intervals whereby your values of y, they are greater than or equals to. So if it is greater than or equals to, greater than meaning that it's positive, right? So it means we'll be looking at these intervals, this side, right? And even this side, you are looking at these intervals on the other side. Okay, so how do you represent this as an inequality? You'll say it's -1/2. You've got x and you've got 2. So from here, let me use a different color. So from 2 going to this side, you are going to the values of x that are greater than 2, right? So it means you are going to the values of x that are positive. So your x, because always when you are reading your inequalities, you must always read from x. So from here going to this side, you are going to the values that are greater than or the values that are positive. So it means your x, it is greater than or equals to 2, right? And then from -1/2 going to this side, we are going to the values of x that are less than -1/2. Ne? So it means your x should be less than or equals to your -1/, less than or equals to x. Ne? Then you get your full marks here by saying x is less than or equals to -1/2, and also for saying x is greater than or equals to 2. You can either write it like this, or you can say x is an element of, you put a square bracket because we said it is less than or equals to -1/2, it's included. So it means you put a square bracket, you say it's -1/2 is 2. X is greater than or equals to 2, then it's going to be 2, then you put a square bracket again. So you can either use this method or you can use that other method. Ne? Let's move to the second question. 1.1.4, it is saying you must solve for x when you are given the square root of 2x plus 5 minus 3 all over the square root of 2x plus 5, it's equals to -2. So you will notice that the square root of 2x plus 5, it's a repetition. It's a repetition. So what you do is that you'll try to find a way to, let me just erase everything here. You have to find a way to make it a little bit easier or simple. So what do you do in such a case? We have to use the method which we call the K method. I don't know if you still remember from term 1, your K method. Ne? So K method, you use it when you've got an equation which is complicated and you want to make it simple. Okay, so I've got the square root of 2x plus 5 minus 3 all over the square root of 2x plus 5. It is equals to -2. So you'll notice that the square root of 2x plus 5 is a repetition. You also have the same thing, which is the square root of 2x plus 5. One person would decide to say, okay, if I divide this by 1, if I say this is all over 1, then I've got 2 fractions, then I can use the scissor method, and after doing the scissor method, I transpose or you do whatever. But it's going to be a little bit complicated. It's going to be a lot of work for only 6 marks. So instead, why not just say, let what is complicated, you say, let the square root of 2x plus 5 to be equals to k. Ne? Meaning that when you see the square root of 2x plus 5, you'll substitute it with k. Minus 3 all over, where you see the square root of 2x plus 5, you substitute it with k, you say it is equals to -2. Ne? From here, you can see you are only dealing with your k. Ne? You've got k minus 3 all over k, it is equals to -2. So let's try and write it in a standard form. Let's remove this k, which is a denominator. So what do? You can either multiply everything, each and every term, by k. If I multiply k by k, I'll get k squared. And if I multiply 3 over k by k, the k and the k will be divided by each other, and I'll get a 1. And then times the negative 3, I get a negative 3. And then it's equals to negative 2. If I multiply the negative 2 by k, I'll get negative 2k. Or you can just use the scissor method. I prefer the scissor method. So scissor method, it means that you'll multiply the k with k. This one, it's over 1. You multiply k with 1. Then you multiply 1 with the negative 3. So let's do that. So if you say k times k, you get k squared. 1 times negative 3, you'll get negative 3. Then if you multiply 1 times k, you'll get a k. Then it is equals to negative 2. And then from there, it's all over 1. You've got a fraction, so you multiply, you cross multiply. So k squared minus 3 times 1, you'll get k squared minus 3. It is equals to negative 2 times the k, you'll get negative 2k. Then I take the negative 2 to the side, it changes the sign to be positive. So I'll get k squared plus 2k minus 3, it is equals to 0. Right? And then from here, you open 2 sets of brackets, or you can use the quadratic formula if you still struggle with factorizing. So you'll have k, then you'll have the factors of 3 that gives you a 2. It is going to be 3 and a 1. Then the sign of a bigger number takes the sign of a middle term. So I'll have positive 3 minus 1. If I say 3 times negative 1, I get negative 3. And if I say 3 minus 1, I do get your positive 2. Remember, you can also use the quadratic formula. So k plus 3, it is equals to 0, or k minus 1, it is equals to 0. So k, it is equals to negative 3. If I transpose the positive 3 to the other side, it gives me negative 3. And then, or k, it is equals to positive 1, because again, you have transposed the negative 1 to the other side, and it gave you a positive 1. But remember, you are not solving for k, you are solving for x. So you need to say, okay, we were not solving for k, but we were solving for x. So it means you still need to substitute back the square root of 2x plus 5 back to where there is k. So it means where there is k here, you'll say it's the square root of 2x plus 5. Where there is k that side, you'll say it's the square root of 2x plus the 5. If you don't do that, you lose the marks. So it is equals to negative 3, and also it is equals to positive 1. Then now you've got a set equation. A set equation, how do you solve it? You have to remove that square root. How do you remove the square root? You'll have to say square both sides, and you also square both sides, and you also square both sides. There is O in between. So if I square this side, the square roots will cancel the 2. Then I'll have 2x plus 5. It is equals to negative 3 squared. I'll get a 9. Then 2x, it is equals to negative 9. I take the positive 5 to the other side. Then it's going to give me a negative 5. Okay. And then you say, oh, the square root of 2x plus 5, if you square like that, you'll get 2x plus 5. It is equals to 1. Then you take the 1 to the other side, you'll get 2x. It is equals to 1 minus 5. Okay, so you'll get 2x, it is equals to negative 1. Sorry, it's not negative 9, it's positive 9. I made a mistake there, because negative 3 squared is going to give you a positive 9. So 9 minus 5, it is going to give you a positive 4. Then you divide by 2, you divide by 2. So your x will be equals to 4 divided by a 2, you'll get a 2. Then this side, you'll get 2x, it is equals to negative 4. If you divide it by 2 and divide it by 2, you'll get that your x, it is equals to negative 2. So your x will be equals to negative 2. But you are not done. You are not sure if both of these values, they do satisfy that equation. So how do you check if an equation, if those values, they do satisfy the equation? So you need to substitute the values that you got, which is x it is equals to 2 and x it is equals to negative 2, where there is the square root of 2x plus 5. So where there is x, you'll substitute 2, and where there is x this side, you'll substitute your negative 2. Let me just erase that other side. Okay, I'll just erase this side now. Okay, so you've got the square root of 2x plus 5, it is equals to negative 3. So if I substitute my x here, I should be able to say the left hand side it is equals to the right hand side. So this side should be equals to this side if you substitute in your positive 2. Sorry, name. So I say it is 2, where there is x, I substitute 2 plus 5, it is equals to negative 3. It's a square root name. So 2 times 2, you get a 4, plus a 5, you get a 9. So you'll get the square root of 9, which is going to give you positive 3. It is equals to negative 3. So you'll notice that the 3 this side, it is positive, and the 3 this side, it is negative. So it means the left hand side, it is not equals to the right hand side. So it means your x, it is not equals to 2. And then again you check your negative 2, you'll say it's the square root of 2, where there is x, you substitute negative 2 plus 5, it is equals to positive 1. It is equals to positive 1. So 2 times negative 2, you'll get a negative 4. Plus a 5, you'll get a positive 1, and a square root of positive 1 is going to give you a 1. Then 1, it is equals to 1. The left hand side, it is equals to the right hand side. So therefore, x, it is equals to negative 2. Name? Okay, so let's see how many marks you'll get for doing all of that. So you'll definitely get a mark for your standard form. You will get a mark for both values of k to be correct. You'll get a mark for saying x, it is not equals to 2, and for saying x, it is equals to your negative 2, and you get a mark for squaring both sides. So all in all, you have your, for simplifying this side, you also get a mark. So that's your 6 marks. Ne? I hope you all understand. Let's move to the next question. So the next question, you've got solve for x and y simultaneously. These are simultaneous equations. But now in grade 11, you've got the one which is linear and the one which is quadratic. So first things first, you need to name your equations. Name. Why are we naming your equations? So that whatever that you are doing, when you say subtract equation 1 from equation 2, or substitute equation 1 in equation 2 or equation 3, the person who's marking can be able to see what are those equations that you are talking about. So you've got y plus x, it is equals to 2. I'll say this is in my equation 1. Then I've got x squared plus 3x plus 8, which is equals to 0. Then I say this is my equation 2. Sorry, here there is y, it's 3xy. So now you need to make equation 3. How do you make equation 3? You have to choose one of between the two equations which is simple. How do you see that an equation is simple? It shouldn't have a number this side. So this side there is only one, or there is only one this side, which is, it means I can make y the subject of the formula, or this side I can make x the subject of the formula and make equation 3. Ne? Okay, but with this one I can't make x the subject of the formula because there's x squared, meaning that at the end I'll have to put a square root so that I can remove that square. So I'll have equation 3 with a square root, so it becomes complicated. Again here, if I make x or y the subjects of the formula, I'll have to divide by x or divide by y to make either x or y the subject of the formula. So it means equation 2, it is out because it is complicated. We always run away from ending up with a square root or ending up with a fraction. So I'll use equation 1 to form equation 3. So I say make equation 1 to be equation 3. So I'll have y, it is equals to 2 minus x. This is my equation 3. So I just made y the subject of the formula. I took x to the other side and it became the negative x. So I'll have 2 minus the x. From there, I need to take equation 3 and I substitute it in equation 2. Why am I not substituting in equation 1? Because I've already used equation 1 to make equation 3. Are we together? So you can't take equation 3 and substitute it in equation 1 again. So you say substitute equation 3 into equation 2. So I have x squared plus 3xy plus 8, it is equals to 0. Remember, you can also make y this is x the subject of the formula. So you can also take y to the side and say x, it is equals to 2 minus y. It's still fine. Okay, so it's going to be x squared plus 3. It's x. Where there is y, you substitute your 2 minus x plus 8. It is equals to 0. So already just by doing this, you have 2 marks. So you get a mark for making equation 3, and you also you get a mark for substituting correctly. Ne? So already you have 2 marks out of that 6 marks. So you don't have a reason for skipping this question. Okay, let's continue. So it is x squared plus the 3x times 2, you'll get 6x. And 3x times negative x, you'll get negative 3x squared. Then plus 8, it is equals to the 0. And so from here, I need to add to the like terms. If I say x squared minus 3x squared, I'll get negative 2x squared. The 6x, I just bring it back as it is, plus 8, it is equals to 0. And then from here, I've got a quadratic equation. So you can either use your quadratic equation formula or you can factorize, it is still fine. But I wanna get rid of the negative 2. So by dividing by negative 2, also dividing by negative 2, and also dividing by negative 2, and also dividing by negative 2. So if I divide by negative 2 throughout, I'll get x squared minus 3x minus the 8 divided by 2, I'll get a 4. It is equals to 0. Ne? Negative 2 divided by negative 2, I get x squared. Positive times negative, I get a negative. 6 divided by 2, I get a 3x minus a 4. Ne? Then from here, I've got a quadratic equation. My equation is simpler, so I can just factorize. So I've got x, and then the factors of 4, that gives you a 3. It is going to be a 4 and a 1. Then the sign of a bigger number, the bigger number takes the sign of a middle term, sorry. So it's going to be negative 4 and a positive 1. Ne? So I'll get x, it is equals to positive 4, or x, it is equals to, if I take the 1 to the other side, it is going to give me negative 1. And then from there, you say substitute x, it is equals to 4, and x, it is equals to negative 1, where into equation 3. So you can either substitute in equation 1, in equation 2, or equation 3. But I'm deciding that I want to use equation 3 because equation 3, it's already in terms of y. It is already y, it is equals to 2 minus the x. So you'll say y, it is equals to 2 minus x, or y is equals to 2 minus x. So firstly, you'll substitute the 4. So I'll get y is equals to 2 minus the 4, which is going to be 2 minus 4. It's going to give you a negative 2. Or y is equals to 2 minus, where there is x, you'll substitute negative 1. Then you'll get y, it is equals to 2 plus 1, which is going to be 3, because negative times negative, it's going to give you a positive. Then 2 plus 1, it is going to give you a 3. So it means when x, it is negative 1, y, it is positive 3, because when we are talking about these two graphs, or two equations, equation 1 and equation 2, we are finding the points of intersections whereby that straight line intersects that parabolic graph. So again, this side I'll have the value of x is 4, so the value of y is going to be -2. You don't have a reason for leaving this this question just because it has got 6 marks. If you feel like after getting those to this, if getting here, maybe you get here, you get a different equation. When you are substituting, it gives you math error because maybe you have made mistakes with the signs when you are multiplying, when you are doing whatever. Please don't stop. Just continue with whatever that you have done which is incorrect. Continue doing it. As long as you have done it correctly, you'll get marks. Because remember, in math we don't mark the answer, but we mark the method. So if the method is correct, then you'll continue getting the marks. So the 6 marks, how do you obtain it? Let's see. So you'll get 1 mark for the correct for making equation 3 correctly. That's a mark. And you get a mark for the correct substitution. And then you get a mark for getting the correct standard form, or getting your equation in a standard form. Then from there you get another mark for factorizing correctly. Then you get a mark for getting your value of x to be 4 and your value of x to be -1. Then you get another mark for getting the value of y as -2 and your value of y as +3. Please don't leave a space in this question. Then you get your full 6 marks. Okay, let's move to 1.3, which is the nature of the roots. It says the roots of the equation f of x is equals to 0 are given as 4 plus or minus the square root of 16 minus 4m into -m plus 5. It's all over 2m. You need to determine the values of m for which the roots will be non-real. So remember the nature of the roots. For the roots to be non-real, or for the roots to not exist, your discriminant needs to be less than 0. So whatever that is inside the square root needs to be less than the 0. Remember the discriminant, it is given as b squared minus 4ac, it is less than 0. But the b squared minus 4ac, where do you obtain it? You obtain it in your quadratic formula, which is given as x, it is equals to -b plus or minus the square root of b squared minus 4ac all over the 2a. So your b squared minus 4ac, b squared minus 4ac, that equation which is under that square root, we say it's your discriminant. So already in this the equation of f of x is equals to 0, they have substituted in that equation of in a quadratic formula. So it means from there you don't need to substitute anything in b squared minus 4ac because they have done it for you. It is under that square root. So instead of b squared minus 4ac, you just substitute 16 minus 4m into -m plus 5 is less than 0. Why are we taking that? Because all of this is equivalent to b squared minus 4ac. If you remember your quadratic formula, whatever that is inside the square root is given as b squared minus 4ac. So you say it is less than 0 so that your roots can be non-real. Then from there, let's multiply. You'll get 16. If I multiply -4m times -m, the negative times the negative, it is going to give you a positive, and then it's 4m squared. Remember, when you're multiplying same basis, you add the exponent. So the exponent here is 1 and the exponent here is 1, so you'll get m squared. Then -4m times the positive 5, you'll get -20m. It's less than the 0. So you'll get 4m. Let's write it in a standard form. So it's going to be 4m squared minus 20m plus 16. It is less than 0. So from here, I prefer my coefficient of a, or my coefficient of m squared, to be positive 1 or to be 1. So it's going, I divide by 4, I divide by 4, I divide by 4, and I divide by 4. If you choose not to divide by 4, remember, it's still fine. You're still going to get the same answer as myself. So if you divide by the 4, you'll get m squared. If you divide 20 plus 4, 20 by the 4, you'll get negative 5m. And if you divide 16 by the 4, you'll get positive 4, it is less than 0. From here, you can see that you've got a quadratic equation. So it means you can factorize, or if you don't want to factorize, you can use, if you don't want to factorize, you can use the quadratic formula. Ne? So I've got m and I've got m. The factors of 4, that gives me a 5. It is going to be a 4 and a 1. And then since it is positive here, for me to get a positive, I need to multiply a negative and a negative. Ne? And then since we are dealing with inequalities, you still need to say its critical values, m minus 4, it is equals to 0, or m minus 1, it is equals to 0. So m, it is equals to 4, or your m, it is equals to positive 1. Ne? And then from here, you still need to draw your number line. So I check my a here. My a, it is positive 1. So if your a, it is greater than the 0, it means your parabolic graph is going to concave up, or is going to smile. Ne? So the number that is less than the other, you put it this side, and then this side you put your positive 4. So from the x-axis going up, the values of y, they are positive. And then from the x-axis going up, your values of y, they are positive. And then from here to here, your values of y, they are negative. Ne? You go to your you go back to your equation. They're saying they're looking for the intervals whereby the equation is less than 0. Less than 0 meaning that it's negative. Ne? So it means we are looking at which intervals? We are looking at these intervals here, ne? Between 1 and the 4, whereby your values of y, they are negative. So how do you represent that? You'll say there is 1 this side and there is 4 this side, and then it's x. From here going to this side, you'll get, from here going to that side, you are going to the values that are positive, or values that are greater than the 1. So you'll say x, it is greater than 1. And then from here going to this side, you are going to the values of x that are greater than that are less than the 4, because you are going to the values that are negative. Ne? So it means you are going to the values of x, or of m. Sorry, I made a mistake. We're dealing with m and not x. Ne? So it means you have m in between. So from here going to the side, you are going to the values of m that are going to be greater than, less than the 4, because you are going to the values that are less than. So your m, it is going to be less than 4. Another thing here, if you have determined one sign, ne, the other one will just follow the other one. They can't face each other. So you can't have m is greater than and it's also greater than. If it's greater than this one, it should be less than the other one. Ne? Then you get your full 4 marks for doing all of that. Let's see how your marks are allocated. So you get a mark for m is, so you get a mark for m is less than the 4. Let me use a black pen. You get a mark for saying m is less than 4, and then you get another mark for saying m, it is greater than 1. Then you get another mark for saying m, it is equals to 4, or m, it is equals to 1. Then you get a mark for saying that your discriminant needs to be less than the 0. Ne? And then you get a mark for getting your standard form, which is m squared minus 5m plus 4. That's another mark, and then you get your total marks of 4 marks. Ne? I hope you all understand. Let's move to question 2 with let's move to question 2 with exponential equations. Okay, so 2.1, they're saying now you must simplify fully without using a calculator. So you shouldn't use a calculator. Ne? So you are given 2 to the exponent x minus 3 times 2 to the exponent x plus 1 all over 2 to the exponent x minus 2. So here you need to remember your laws of exponents. Ne? When you are multiplying the same bases, you add the exponents. So if I have 2 to the exponent x times 2 to the exponent negative 3, if I multiply the 2, I'll get 2 to the exponent x plus minus 3, which is just x to the 2 to the exponent x minus 3. So before this became 2 to the exponent x minus 3, initially it was 2 to the exponent x times 2 to the exponent negative 3. So it's very important that when you get equations like this, you need to write your number as a prime base, and then from there you need to separate your exponents. Ne? So it means when it's given in this format, you need to take it back to that format. Ne? Okay, let's do the first question. So you are given 2 to the exponent x minus 3 times 2 to the exponent x plus 1 all over 2 to the exponent x minus 2. Remember, in this question, you can't use a calculator. So we need to separate. When you're separating here, you'll say it's 2 to the exponent x times 2 to the exponent minus 3. Minus 3 times, again, if I separate this side, I'll get 2 to the exponent x times 2 to the exponent 1. Can you see? So even with the denominator, I'll get 2 to the exponent x times 2 to the exponent negative 2. Ne? So you just separate your exponents, and then from here you check if you've got anything which is common. Do you see anything which is common here? Yes, I have 2 to the exponent x, and I also have 2 to the exponent x, right? So you can take the 2 to the exponent x and the 2 to the exponent x as your common factor, because now you need to factorize. Ne? So you say it's 2 to the exponent x into 2 to the exponent x is common. I've taken it out as a common factor. So it means if I take out 2 to the exponent x as a common factor, then I'll be left with 2 to the exponent minus 3, right? And then I have minus 3. I took out the 2 to the exponent 3 as a common factor, so it means I'm left with times 2 to the exponent 1. Then I close the brackets. I say it's all over. I still have 2 to the exponent x times 2 to the exponent negative 2 as my denominator. Okay, so 2 to the exponent x, it divides the 2 to the exponent x. So if 2 to the exponent x divides 2 to the exponent x, it means I'll be left with 1. Ne? And then I have 2 to the exponent negative 3 minus the 3 times the 2, I get a 6. Okay, let me just because I won't have enough space, let me just get to the point. Okay, so here the 2 to the exponent negative 3, I can write it as 1 all over 8. So that I don't confuse you, ne? Because I'm sure you're asking yourself, where is the 8 coming from? So the 2 to the exponent negative 3, remember from the laws of exponents, if you have 2 to the exponent negative 1, you can write this as 1 all over 2 to the exponent 1 like that. Ne? And if you have 2 to the exponent minus 3, you can write it as 1 all over 2 to the exponent 3. So even this side, the 2 to the exponent negative 3, I'll write it as 2 to the exponent positive 3. So if you want to make the exponent which is negative to be positive, you write it as 1 all over that number that you are given. So it's minus 3 times the 2, I'll get a 6. It's all over. As a denominator, I have 1 all over 2 to the exponent 2. Remember, you can use a calculator. So if I simplify here, I'll get 1 all over 8 minus 6 all over 1. The 6 is all over 1. And then I say it is all divided by 1 all over 2 to the exponent 2. Let me just write it as 4. Okay, so my 2 to the exponent 2, it is given as a 4. Ne? Okay, from here I can do my scissor method. So 1 times 1, I get a 1. 8 times the 6, I get a 48 minus 48 because it's 1 times negative 6. And then it's all over 8 times 1, I get a 8. And then I say times the 1 all over 4, I can write it as 4 all over 1. And then from there, 1 minus 48, I'll get minus 47 all over the 8 times the 4 all over 1. And then from there, I can just multiply. You multiply the numerators together, then you multiply the denominators together. So if I say 47 times the 4, I'll get a negative 188 all over the 8 times the 1, I'll get the same 8. Then you need to divide 188 divided by 8, and then you'll get 47, negative 47 all over 2. Then you get your full 4 marks. Let's see how you obtain the 4 marks. So for separating the exponents, you do get a mark. For taking out a common factor, you do get a mark. Then you get a mark for simplifying, then you get a mark for the answer. So you get your full 4 marks for doing all of that. Easy, ne? Okay. We move to 2.2.1. You are given 2 minus 16x to the exponent negative 3 all over 2. It is equals to 0. They say you must solve for x for the 3 marks. And then, so first things first, we need to isolate our x. So you'll have negative 16x to the exponent negative 3 all over 2. It is equals to, you need to take the 2 to this side. Since it's positive, it is going to change the sign to be negative 2. You need to isolate this by dividing by negative 16 and also dividing by negative 16. So negative 16 divided by negative 16, you'll get positive 1. Then you'll be left with x to the exponent negative 3 all over 2. It is equals to 2 divided by 16. That should give you 1 all over 8. Then you have x to the exponent negative 3 all over 2. It is equals to, I can write the 8 as 1 all over 2 to the exponent 3, right? Then I can take this and make it a numerator. And if you do that, then it means you will have 2 to the exponent negative 3, right? And then from there, I need to remove that exponent. How do you remove the exponent? You need to multiply the exponent with its inverse. So you'll have multiplied by negative 2 all over 3. Then you multiply by negative 2 all over 3, because what you have done on the right, you also do it on the left. Okay, and then from there, you'll have x to the exponent negative times negative, you'll get a positive. Then 3 times 2, you'll get a 6. Then 2 times 3, you'll get a 6. It is equals to, the negative 3 here, it's all over 1. So you'll get 2 to the exponent negative 3 times negative 2. It is going to give you a positive 6 all over 1 times the 3, you'll get a positive 3. So x, the exponent divided, the 6 divided by 6, you'll get a 1. So x will be equals to 2 to the exponent. 6 divided by 3, you'll get a 2. So it means your x, it is equals to 4. And we only have one solution, because remember back in term 1, if you have x to the exponent p all over q, you look at that value. So if your p is an even number, and then your q, it is an odd number, then it means you are going to have two solutions, right? And then if your p is an odd number and then your q is an even number, then you are going to have only one solution. So it means in this case, you only have one solution, which is x, it is equals to 4. Then you get your full 3 marks. So let's see how you are going to obtain your 3 marks. So you'll get a mark. You'll get a mark for saying x, it is equals to 4. And then you'll get a mark for writing 8 as a prime base. Then you get another mark for multiplying the exponent by its inverse. Then you get your full 3 marks. Now, let's move to 2.2.2. Okay, 2.2.2, you are given 4 to the exponent x plus 8. It is equals to 9 times 2 to the exponent x, right? Okay, so first things first, here we need to write the 4, the 8, and the 9 as its prime base. The 8, I don't think we need to do it though. So here I'll write it as 2 to the exponent 2. So the 4, I write it as 2 to the exponent 2. But there is that exponent x. It's still there. You don't just throw it away. You still have plus 8, it's equals to the 9. I don't have to write it as a prime base as well. So I have 9 times 2 to the exponent x. Okay? So I'm interested in the exponent. You'll notice that the exponent here is 2x, and then the exponent here, it is x. So you can see that there is a quadratic equation that is being formed, but you won't be able to see it nicely. So let's just do everything. So it's 2 to the exponent x plus 8, and then this side, I take it to this side, I get negative 9 times 2 to the exponent x, it is equals to 0. Remember, if you take it from this side and you bring it this side, it's going to change the sign to be negative because it was positive initially. Ne? Okay, so again, you still can't see what is really happening here. Can you separate? You can't separate. So instead, let's say let k to be equals to 2 to the exponent x, so that everything will look a little bit simple, because right now it is looking really complicated. Okay, so I let 2 to the exponent x to be k, ne? So it means here, since I have 2 to the exponent x, can you see that 2 to the exponent x, ne? That you can represent it as k. But there is that 2 which is left as an exponent. So you still substitute that 2. Then it is minus 9 times the 2 to the exponent x. I write it as k because I said let 2 to the exponent x to be equals to k. Then the 8 that is left, I just put it there. It is equals to 0. So I don't know if you can notice from here, this is a quadratic equation. So you can use a quadratic formula to get your factors of k, or to get your values of k, or you can just factorize. Ne? So I'm going to factorize because it's going to save time, but you can use the quadratic formula. So I substitute 1k, I substitute another k. The factors of 8, that gives me 9. It's going to be 8 and a 1. So 8 times 1, I do get a 8, and then 8 plus 1, I do get a 9. Ne? So since it's positive, it's going to be negative times negative. Then I'll get k minus 8, it is equals to 0, or k minus 1, it is equals to 0. So I've got k, it's equals to 8, or I've got k, it's equals to 1. But remember, you are solving for x and not k. Ne? So you can't just leave your answer at k is equals to 8 and also k it is equals to positive 1. So you still need to say, since you said let k to be equals to 2 to the exponent x, it means you still need to substitute the 2 to the exponent x where there is k, because you are solving for x. Ne? So you'll have 2 to the exponent x where there is k, it is equals to 8, or where there is k again, you'll have 2 to the exponent x, it is equals to the 1. So you have 2 to the exponent x, it is equals to the 8. I can write it as a prime base, and it's going to be 2 to the exponent 3. Remember, if you can't write a number as a prime base, you can just use a calculator. You can still using a calculator. I don't know if it makes sense. No one will notice that you have used a calculator. So how do you find the prime base of a number? So in your calculator, so since you have 8, you wanna get a prime base of 8. You'll say 8, you press 8 in your calculator, and then after pressing the 8, you'll press the equal sign, and after pressing the equal sign, you'll press the shift, and after pressing the shift, then you'll press that button that is written fact, or that has got something that looks like this, like those small cheese. So you just press that button, then you'll get 2 to the exponent 3. So always when you're trying to write a number as a prime base, just follow those steps, then you'll get your prime base. So why are we writing it as a prime base? Because we want to make the bases to be the same. because according to the laws of exponents, when the bases are the same like this, you've got a 2, you've got a 2, then it means you're allowed to say x it is equals to 3. You are allowed to equate the exponents. Ne? Or this side you've got a 1. How can you write a 2 in such a way that it has got a base which is a 1 in such a way that it has got a base of 2? You have to say 2 to the exponent x it is equals to a 1. I can write it as a base of 2 and put the exponent which is 0. According to the laws of exponents, any number raised to an exponent 0, that number is equivalent to 1, if you still remember. So now the bases, they are the same. I've got a 2 and a 2. So now I'll say x it is equals to 0. So since the bases are the same, I am allowed to equate the exponents. Then you get your full 4 marks. Ne? So let's substitute. You're gonna get your full marks. You get a mark, you get a mark. Then it is how many marks? It is 4 marks. Ne? So you get a mark here and you also get a mark here. So you get a full 4 marks. Let's see if this equations, if the x is equals to 3 does satisfy the equation. Ne? I did tell you how to check that. So where there is x, you substitute 3. So it means you'll say it's 2 to the exponent 3. You'll get a 8. Okay, that one is correct. Then let's substitute this side as well. We say 2 to the exponent 0. You do get a 1. So it means we are happy with our solution. Then you get your full 4 marks. Then we move to 2.2.3. Can I erase? I'll erase everything else because I need to solve that one. Okay. Okay, now let's do 2.2.3. So 2.2.3, you are given the root x9 is equals to 243. So here I can write 9 as a prime base, then it's going to give me 3 to the exponent 2. It is equals to 243. I can write it as a prime base as 3 to the exponent 5. Let me just double check with my calculator. So it's 243. You say equal sign, you say shift, then you say fact, then you'll get 3 to the exponent 5. Okay, and then from there I need to remove that x root name. So let's go back to our basics. So if you've got a square root of 2, you can remove the square root there by saying 2 to the exponent 1 over 2, right? Your square roots, it's equivalent to the exponent 1 all over 2. Then if you've got the third root or cubic root of 2, then if you are removing the square roots there, you'll get 2 to the exponent 1 over 3, right? And if you've got a fourth root of 2, you can remove it by saying 2 to the exponent 1 over 4. So if it's a fifth root, you can remove it by saying 2 to the exponent 1 over 5. If it's a sixth root, you can remove it by saying the exponent 1 all over 6. If it's a seventh root, to the exponent 1 all over 7. You get the idea, no? So from here, you'll say it's 3 to the exponent 2. Then the exponent, since I've got x, it's the x root. So it means you'll have 1 all over x, right? And then what you say, it's equals to 3 to the exponent 5. You have removed that x root. And that 2, it is all over 1. So let's do our multiplication. So 2 times 1, the numerators multiply each other. So 2 times the 1, I'll get a 2 all over 1 times the 3. Sorry, 1 times the x, you'll get an x. it is equals to 3 to the exponent 5. So now I want to remove that exponent, which is a 2 all over x. How do you remove that exponent? You multiply by the inverse of that exponent. So I'll multiply by x over 2. And what I have done this side, I need to do it on the other side as well. So the 5, it's all over 1. So I multiply it by x all over 2. Okay, so I'll have 3 to the exponent 2 times x, I'll get 2x. X times the 2, I'll get 2x. Then 2x divided by 2x, I get a 1. So I'll get 3 to the exponent 1. It's equals to the 5 times x, I'll get 3 to the exponent 5x all over. Oh, I actually didn't even have to do all of that because the bases, it's 3 and 3. So I can just equate the exponents. Let's just continue. It's fine. Nah, it's a waste of time. We don't even have to do all of that. We don't have to multiply the inverse. Why don't we have to multiply by the inverse? Because it's already a base of 3 and a base of 3. And the laws of exponents says if the base is 3, if you're multiplying by a base of 3, here it's 1 over x. If you've got the bases that are the same, you just equate the exponents. Ne? So 2 times the 1, you got a 2, and then 1 times x, you get an x. So you had 3 to the exponent 2 over x. It is equals to 3 to the exponent 5. Ne? So from there, the bases are the same. You just equate the exponents. So you'll have 2 all over x. It is equals to 5. This one, it's over 1. Then from here, you need to solve for x. How do you solve for x? Cross multiply x times 5, you get 5x. It is equals to 2 times 1, you get a 2. You divide by 5, you divide by 5. Then your x, it is equals to 2 all over 5. And then you get your full 3 marks. Let's see how you get your 3 marks. So you obviously get a mark for the answer. You get a mark for removing that square root. Then you get a mark for dropping the exponents. Then that's going to be your full 3 marks. Okay. Let's move. Then you've got question 1, solve for x in each of the following. You've got x squared plus x minus 12. That's a quadratic equation. This is just a repetition. You can just use a quadratic formula, or you can factorize and get your factors. 1.1.2, you've got the square root of 2x plus 1. It is equals to x minus 1. I can do this one. Okay, so you've got the square root of 2x plus 1. It is equals to x minus 1. So from here, you need to remove the square roots. So you square both sides. You square both sides. The first step, you need to isolate your set. Ne? So in this case, you don't have to isolate your set. So what do? You just square both sides so that you can remove the square roots. So the square roots and the 2 will go out. So then you'll be having 2x plus 1. It is equals to here. The 2 means that whatever that is inside the brackets, it's repeated twice. Meaning that you will have x minus 1 and again another x minus 1. So you'll have 2x plus 1. It is equals to, you multiply the first terms together. Then you'll get x squared. And if you multiply the x and negative 1, you get negative 1x. Negative 1 times x, you get negative 1x. And negative 1 times negative 1, you get a positive 1. So you'll get 2x plus 1. It is equals to x squared minus 2x plus 1. From here, you just add your like terms, which is negative 1 and negative 1. Okay, from here, let's take all of this to the other side. So you'll have x squared minus 2x plus 1. If I transpose 2x, I get negative 2x. And if I transpose the positive 1, I get negative 1. It is equals to 0. So I'll be left with x squared. The negative 2x and negative 2x, I'll get negative 4x. Positive 1 and minus 1, I'll get a 0. Then it is equals to 0. So from here, I can use the quadratic formula. If you use a quadratic formula, your a, it is going to be 1. Your b, it is going to be negative 4. Then your c, it is going to be 0. But with me, I'll rather use a different method. What is that method? A simple. You look for what is common here. I can see that x is common, so I take out x as a common factor. Then if I take out x as a common factor, I am left with 1x minus a 4, because I have taken this x as a common factor, so it is equals to 0. Then x is equals to 0, or x it is equals to positive 4. So x will be equals to this, or x will be equals to the positive 4. All right. And then since we are dealing with our set numbers or set equations, then you need to check which of these values of x satisfies that equation. How do you check that? Where there is x in your equation, you'll substitute 0. Where there is x in your equation, you'll substitute 0 again. So if this side it is equals to this side, then it means x it is equals to 0. If you check with 4 again, if the other side is equal to the other side, then it means the 4 satisfies the equation. So let's do the checking. Okay, so you get the square root of 2x plus 1. It is equals to x minus 1. So it's the square root of 2. Let me start with 0. So I substitute 0 plus 1. It's equals to 0 minus 1. So 2 times 0, I'll get a 0. Plus 1, I'll get a 1. What is the square root of 1? It is 1. It is equals to negative 1, right? So this side, it's not equals to the other side. So it means x is not equals to the 0. It's very important, guys, because you get a mark for doing that. So you get a mark for squaring both sides. You get a mark for the standard form. You get a mark for both values of x to be correct. Then you get a mark for correct factorizing. Then you get a mark for saying x is not equals to 0, or for choosing one value of x. Why am I choosing a 4? Just take the 4 and substitute. You'll notice that if you say 2 times the 4, you'll get a 8. 8 plus 1, it is 9. Then the square root of 9 will give you a 3. And then if you substitute the 4 this side, you'll get 4 minus 1, which is going to be a 3. So it means the left hand side, it is equals to the right hand side is equals to the left hand side. So it means x it is equals to 4. So that's how you get your final mark of that one, and then it gives you a total marks of 5. And then the 1.1.3, I think it's a repetition as well. It looks exactly the same as 1.1.2. Okay, so here you are solving for x again. So you've got 2 to the exponent x square root x, it is equals to 2 to the exponent 27. So the bases here, they are the same, right? So you just equate the exponents. Then you'll be having x root x, it is equals to 27. So how do you remove the square roots? I told you, you square both sides. Ne? And then you've got an inequality. We have done inequalities. You'll just do it yourself. And then 1.2.1, solve for x if f of x it is equals to 0, correct to 2 decimal places. So that one, you just equate your f of x to 0, then you solve for x. And then 1.2.2, it says hence or otherwise, calculate the value of d for which f of x squared plus 6x minus d, it is equals to 0, has equal roots. For you to have equal roots in the nature of roots, your discriminant needs to be equals to 0, right? And then you substitute your b, which is going to be 6. You substitute your a, which is going to be 5. Then you substitute your c, which is going to be negative d. Then you solve for d, simple, and you get your full 3 marks. Then solve for x and y simultaneously. So here you need to name your equations the way I said it in the first question. Then you make the first equation to be equation 3 because it has got the coefficient of 1. So you can make x the subject of the formula. Why are we not making y the subject of the formula? Because if you are removing that negative 2 there, you'll get an x divided by negative 2 and also divided by negative 2 on the other side. Right? Okay, so meaning that you'll be dealing with fractions, and we are running away from the fractions. So you make x the subject of the formula, then you substitute in equation 2, obviously, because you can't substitute in equation 1 because you've used equation 1 to make equation 3. Then you solve for x and y simultaneously. Okay, again, this is a repetition. Here you have to separate, then take out a common factor. Yeah, then you'll just continue with the rest. Ne? Okay, let's quickly look at the functions and the graphs. So functions and graphs, we've got a linear function, we've got a quadratic function, an exponential function, then we have a hyperbolic function. So you should be able to sketch and interpret when they have sketched the graph for you. Ne? So what you should be knowing already, you should be knowing how to sketch a straight line, parabola, hyperbola, and exponential functions with 1 or 2 parameters using a dual method, intercept method, sorry. Then your straight line, it is given as f of x is equals to ax plus q, whereby the a, it tells you about the shape of the graph, if either it is going to be an increasing or decreasing function. Then your q, it tells you about the y-intercept and also shifts your graph vertically. So it can, if it's plus q, it shifts your graph up, and if it's minus q, it shifts your graph downwards. And then again, you've got f of x that is equals to a into x plus p squared plus q. Again, your p, it shifts your graph horizontally. So if it's plus p, then your graph shifts to the left, and if it's minus p, your graph shifts to the right. And then the q shifts your graph upwards, so it can either move up or down. Then your a, it tells you about the shape of the graph. So since it's a parabola, if your a, it is greater than 0, then your graph is going to smile, and if your a, it is less than 0, then your graph is going to frown, or it's going to concave down. And then let's move to a hyperbola. Hyperbola, we've got f of x, it is equals to a all over x plus p plus q, whereby your a, it tells you about the shape of your graph. So if your a is positive, it is going to have an arm in the first quadrant and in the third quadrant. And if your a, it is less than 0, then your arm is going to be in the second quadrant and also in the fourth quadrant. And then your p, it shifts your graph to the right or to the left. And also don't forget that your p, it is going to be your vertical asymptote. Ne? So, and then your q, it shifts your graph upwards or downwards, and also your q, it is going to be your horizontal asymptote. And then moving to an exponential function, which is given as f of x, it is equals to a times b to the exponent x plus b, plus the q, again your q, it is your horizontal asymptote. So you also need to know the effect of parameters a, q, and p on all the functions mentioned above, and I just explained that. And also in that past lesson, I did explain the effect of the parameters a, q, and the p. So determine the domains and the range of the functions mentioned above. So you should be able to determine the domains, which is the values of x that are covered by the graph, and also the range, which is the values of y that are covered by the graph in all of the functions that are mentioned above. Okay, let's move to the summary. So when we are finding the x-intercept, you need to substitute y with 0, then solve for x. So always when it's x-intercept, you need to let y to be 0. And when it is y-intercept, then you need to substitute x with 0, then you solve for y. Then when you are finding the horizontal distance between 2 points, you need to say the x on the right minus the x on the left. Then when you are finding the vertical distance between 2 points, you say y at the top minus the y at the bottom. Then when you are finding the average gradient, obviously you need to say change in y over change in x, which is going to be y2 minus y1 all over x2 minus x1. Or you can say f, and then you substitute that value of x that you are given, and then you say f, where there is x, you substitute that value of x that you are given, then you'll get the corresponding value of y, you get the corresponding value of y all over x2 minus x1, so that you can get your average gradient. Okay, let's quickly go through that. Question 5, you are given that f of x, it is equals to negative 2x squared plus x plus 6. So 5.1, they say determine the coordinates of the turning point of f. So how do you find the turning point when your equation is given in terms of ax squared plus bx plus c, it is equals to 0? We say it's x, it is equals to negative b all over 2a, right? So it's going to be x, it's equals to negative. Your b, you know that your b is given as the 1 all over 2. Then your x, it is given as negative 2. This is 5.1. Then your x, it is equals to negative 1 divided by 2 times negative 2. It is going to give you 1 all over 4. Name? We are finding the coordinates, meaning that we must have the value of x and the value of y. So after that, you need to take this value of x, you substitute where? Substitute in your original equation so that you can find the corresponding value of your y. So you say f into 1 over 4, it is equals to negative 2 into 1 over 4. You square plus 1 over 4, close the bracket, plus 6. Then you substitute everything in your calculator as it is, you'll get you get 49 over 8. So it means when x is 1 over 4, y it is 49 all over 8. So you can either do it like this, or you can find the x-intercept by letting y to be 0. So if you find the x-intercept, you'll find two values of x. So since it's negative, that it's going to concave down. So since your a, it is less than 0. So you'll have this value of x and have that value of x. For you to find the value of x of the turning point, you'll say this value of x plus this value of x, then divide by 2. Like when you are finding the midpoint. So you'll say this value of x here plus this value of x here, you divide by 2, you shall get 1 all over 4. Then that value of x that you get, you take it, you substitute in your original. Are we together, guys? Okay, let's move to 5.2. 5.2, it is saying we need to find, I think it's the y-intercept. Yes, it's saying we must find the y-intercept. So you'll have negative 2x squared plus x plus 6. Y-intercept, remember we have said you need to let y to be 0. So it's going to be f at 0, it's equals to negative 2, 0 squared plus 0 plus 6. So your f at 0 is equals to 6. So when x is 0, y it is 6. Then you move to 5.3. 5.3, it is saying you must determine the x-intercept. So x-intercept, how do you find it? You must say let y to be 0. So where there is y, you substitute 0 in your equation. Then it is equals to negative 2x squared plus x plus 6. And then from there, you use your quadratic formula, or you can just factorize. So I'll say it is x, it's equals to negative, your b, it is 1 plus or minus the square root of your x, your b, it is 1 square minus 4, a, c, it's all over 2, your a is negative 2. Let me just continue this side. So your x will be that, or your x will be equal to this. So let's just substitute everything as it is. So it's negative 1 plus So you've got negative 3 over 2, or it's negative 1 comma 5. Or x, it is equals to 2. So you've got that and you've got this. So when x is 2, y is 0. And when x is negative 1 comma 5, y is 0. I think that is just 1 mark for the y-intercept. So this one, you get a mark here, you also get a mark here, that's 2 marks. And then here you only get 1 mark. Why is it only just 1 mark? Because you can find the y-intercept just by looking at the graph. Remember, your value of c, it's your y-intercept. Okay, then the other one is 2 marks. So for letting x to be 0 here, and for getting those both values of x to be correct, then again you are getting your 2 marks. Then let's move to 5.4. 5.4, it is now saying sketch the graph of f showing clearly all intercept with the x's and the turning point. So obviously in your f of x, you noticed that your a, it is less than 0, so it means your graph is going to concave down, ne? Okay, so this is me. Okay, so it's negative 1, negative 2, negative 3, negative 4, negative 5. It is 1, 2, 3, 4, and 5. Here I'll use 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. Okay, so I've got my turning point at your TP. We said it is, let me use a black color. We said our turning point was, we said it's 1 over 4 is to 49 over 2. Is it 49 or 48? Let's just confirm. Okay, we said it is 49 over 8. 49 over 8. So if I write it as a decimal, 1 over 4, it is going to be 0.25, which is 0.3. So positive, your x is positive 0.3, so it's going to be just before the 0. It's going to be somewhere here. And then 49 over 8, it is going to be 6 comma something. It's 49 divided by 8. It's going to be 6.125, which is 6.13. 6.13 is just going to be a little bit above the 6, so it's going to be somewhere here. And then your y-intercept is at exactly 6, so it's going to be just a little bit below. Then you've got your negative 1.5 is your y-intercept. Then you've got your x is equals to 2 as your y-intercept again. So what do? You just combine your points and also just combine your points. I'm so sorry guys, the screen, it's a little bit slippery. Okay, so here we had Cartesian plane 1, 2. So our point was here. We had a point here, and we had a point just after the 6. So it was like this, and it was like this. Yes, that's my parabola. You just connect the dots, ne? So make sure your Cartesian plane, is correct, ne? Okay, so that's 3 marks. You get a mark for the shape, correct shape, that it's concaving down. Then you get a mark for the turning point. Then you get a mark for the x-intercept and the y-intercept. Another mark for the intercept. Then that's your full 3 marks. Simple, ne? I know. Let's move to The next question, do we have another question? Okay, so now 5.5, it is saying determine the values of k such that f of x it is equals to k has equal roots. So for you to have equal roots, your discriminant needs to be equal to the 0, ne? Or if I'm just looking at the graph, because it's just 2 marks, I think we should just look at the graph. If you are not looking at the graph, you can say, let me show you. I'll just show you on the side. So they said f of x it is equals to k, right? It should have equal roots. So for it to have equal roots, your discriminant needs to be equals to 0. So it means you'll say f of x, you know that it's given as negative 2x squared plus x plus 6, it is equals to k. Then it's going to be negative 2x squared plus x plus 6. You transpose the k to the other side, it becomes negative k. You say it's equals to 0. Then your a here will be negative 2. Your b, which is the coefficient of x, it is going to be 1. Then your c, it is going to be given by everything that is left to the side, which is going to be 6 minus k. So for that equation to have equal roots, it means your discriminant needs to be equal to 0. Discriminant is given as b squared minus 4ac, it is equal to 0. Where there is b, you'll substitute that. Where there is a, you substitute that. And then where there is c, you substitute all of that. Then you'll get your k, it is equals to, you'll just solve for k. You'll get your values of k. But I am just going to use the graph. Why am I using the graph? Because it is only just 2 marks, ne? But at the end of the day, you just want to get marks. So if you can't use the method of just looking at the graph, make sure that you use the method of the discriminant, ne? So don't just lose marks. So for this graph to have equal roots, it's where we said it's f of x, it is equals to k, right? So f of x, you know that it's y. So it's y, it's equals to k. For this graph and this graph of f of x to have equal roots, it means where they intersect each other, they should have equal roots. So I can, if I put, if this graph of y is equals to k, it intersects the graph here, I won't have equal roots because this side I'll have the value of x, which is positive, and the value of x, which is negative, right? And then again, if it intersects here, again, I'll have the one this side and the one this side. The roots, they are not equal. Again, when it intersects here, I'll have this value of x and this value of x. So those values of x, they are not equal. Again, if it intersects here on top, I'll have this value of x and that value of x. So they are not going to be equal. Again, on top, it's going to be this value and that other value up until at a turning point, because at the turning point I've got only this value of x. So it means here I do have equal roots at the turning point, right? What is the turning point there? It is 49 over 8. So it means you'll say your k should be equals to 48 all over 8 for you to have your equal roots. Then it is going to be 2 marks like that. So even here you'll get k is equals to 48 over 8. Sorry, it's not 48, it is 49. Your value of y of the turning point is 49, not 48. I made a mistake, I'm sorry for that. So it is 49 all over 8. Then you get your full 2 marks. Ne? Even if you use the other method, it's still fine. At the end of the day, we want to get the marks. Okay, let's move to 5.6. 5.6 is saying if the graph of f, it is shifted 2 units to the right. 2 units to the right. So it means your x, it is equals to the value of your value of x of the turning point, which is 1 over 4. Okay, let me not do it like that because I'm going to confuse you. So if it is shifted 2 units to the right, it means here you will have plus 2, ne? Right? So you'll have plus 2 and then 1 unit upwards. So it means your p, it is going to be plus 1. Are we together? So if I take the 2 and I bring it this side, I'll get x minus 2, it is equals to 0. You'll see why am I doing all of that. So I said it's x, it's equals to 2, ne? Positive 2, and then p, it is equals to positive 1. This is 1 unit upward, and then this is 2 unit to the right. So they said we must give our equation in terms of a into x plus p squared plus the q. So I do know my a, it is negative 2. Then my p, it is plus 1 over 4 I squared plus the q, it is given as, sorry, your p, it is 1 over positive 1 over 4. So if I put it inside the bracket, it's going to be negative. It's going to be negative 1 over 4. Then the q, it is given as 49 over 8. We are talking about the original equation, the equation of f of x, ne? So your h of x will be given as, now we need to translate this by 2 units to the right. So 2 units to the right, it means the 2 will come this side, then I'll have x minus 2. So it's going to be x minus 1 over 4 minus the 2, then I square plus 49 over 8. Then this one, I need to shift it 1 unit upwards, so it's going to be plus 1. So the new equation will be negative 1 over 4 minus 2, it's going to be x minus 9 over 4. You square plus the 49 over 8 plus 1, it is going to be 57 all over 8. So it means this is your new equation of h of x. Then you get your full 3 marks. So you get a mark for changing this one, you get a mark for changing this one, and for the whole equation, then that's your full 3 marks. Thank you for tuning in. I created that worksheet number 1. Please go home and do it. Worksheet number 2, then worksheet number 3, and then that worksheet number 4 with algebra. And thank you for tuning in. Let me just open the worksheets for you so that you'll be able to take a picture or write down the equations or the questions, so you should be able to do it. Thank you.